Hi everyone, welcome to our video on finding the equation of a line in general form. So we on the previous video, if you're going in order of these, we were finding the equation of a line in slope-intercept form. That is the most common case throughout your whole math career. That's usually the way that we would write it. However, just in case they want it this way, let's do a couple of examples. So here's our three different forms to the line. So we have the slope-intercept, we have the point-slope, and we have the general form. Now, let's find an equation for each line in the form. And notice the way that they give it to. Here I used capital letters. Here they're doing lowercase letters just to mix it up. So it's the same deal. A, B, and C are integers. Here they do not want them to have any common factor, though. Okay, so that will not be a huge deal when we get to it. And they do want the A to be positive. So that's what that means. So A is greater than or equal to 0, so they want A to be positive. So A is positive. Okay, so they're basically saying make sure the first term is positive. They don't like to have that as a negative. Well, it doesn't really change the way that we break down the problem from what we did in the previous video. We still need a slope. And we'll still need a point. Okay, so let's find those. So on this, they gave it to us in words versus just a straight up point. So it says an x-intercept of 2. So that as a point is really 2, 0. Y-intercept of -6. So that as a point is really 0, -6. So remember, an x-intercept is on the x-axis. So it's telling you what your x value should be. And then y is instantly 0. Y-intercept means that the point's on the y-axis. So that's telling you what your y value should be. And then instantly x is 0. Okay, anyway, so these could be our points. So here's like x1, y1. Here's x2, y2. And so we already have a point. And again, it doesn't matter which one you use. Let's go ahead and just say, here's my x1, y1. And these numbers are, you assign them. So if I really wanted to, I could call this x2, y2, and this one x1, y1 if I want to. So it is up to us. But let me go ahead and squiggle that out. Okay, so it doesn't matter as long as one is one and the one is the other. So don't make them both like x1, y1. As long as you just switch the numbers, you're good. Okay, anyway, so we have our point. Now we need the slope. Well, we can find our slope with our equation, or we can sketch a quick picture. Let's go ahead and sketch it. So there's 2, 0. And then 0 and -6. So 1, 2, 3, 4, 5, 6. This, I think, is nice enough to do just here on my picture. I'm going to just make my rise over run triangle. Notice it's positive slope. And it looks like, well, I can run over 2. So from the axis over 2 is 2. And then I can rise up 6. So it looks like our slope is rise over run, which is, let me mark them, rise over run, so 6 over 2, and then, well, that reduces to be just 3. Okay, so we have our slope, and we have our point, and then, well, I'm going to do this the same way that I did in the last couple problems, where now that I have the slope and the point, we can set up our equation, and we'll plug everything in. Okay, so we've got the slope is 3, but our y1 using 2, 0, so it's 0, which is good to have. Our slope is 3, and then we have x minus x1, which is 2. And then we'll do what we did in the previous problems too, where we can distribute the 3. So we've got y minus 0 would be just y. And then 3 distributes, so we have 3x minus 6. And then this is the answer if they wanted it in slope-intercept form, because y is by itself. But they want it in general form. So that means they want the x and the y to be on the same side. So all I have to do to get that going is, well, let's get our x on the same side as y. So let's just subtract that 3x over. So we have -3x plus y. Remember, if it's blank, it would be really positive. So -3x plus y. And then equals that zeroed out to give us -6. Okay, so now it's in almost the general form, but they said make sure that this stays positive. So all we have to do is change all the signs by multiplying everything by -1. Okay, because they said this needs to be positive. Well, -3 and a -1 would make it positive. Just make sure you're doing it to all other terms. And when we do that, we would have positive 3x, negative y, so minus y, equals -6 times -1 is positive 6. There we go. Okay, and then as a very quick eyeball check, if I plug 2, 0 in, so if I plug x for 2 and 0 for y, notice that that is 6, so it is a match for this equation. And then if we plug the other points in, so 0 for x and -6 for y, notice that's also would be 6, because 3 times 0 is 0, double negative is positive. So it gives us the same, so it shows that we're correct. So you can always plug in points into your equation to verify that it is correct. Okay, so let's see another case. I think I have 2 others in this video. So let's break this one down. Okay, so they're saying through this point in parallel to this equation. All right, remember parallel means we need the same slope as whatever's going on here. So they gave us the point again. Let's go ahead and just mark it to the side like we did last time. So our point is 10 and -8. So that is our x1 and y1. Our slope, well, our slope is found from this equation. It has the same slope as this, but it's not in the correct form. So let's go ahead and get the form. So we need to solve for y. So let's subtract the 4x. So if we minus 4x to both sides, I'm going to squeeze it in between the equals and the 9 on the right side. So we would have -3y equals -4x plus 9. And then if we divide everything by -3, we'll get our slope. So it will be in the correct form. So we have y equals 2 negatives is positive, and then 9 divided by -3 would be -3. But the important thing out of this is right here. That is our slope. So our slope is 4/3. It's parallel. It's the same as this. If it's perpendicular, remember you would flip it and then make it the opposite sign. Okay, so we do have our slope though. Let me go ahead and cloud it. All right, so we have our important pieces. And then again, just like last time, let's go ahead and set up our equation now. And then we'll sub in all of our values. So we have y minus y1, which is -8, equals the slope of 4/3 times x minus x1. x1 is 10, like that. And then we'll distribute. And let's go ahead and do the double negative on the left side. So minus a negative is plus. 4/3 distributes. It would be 4/3 x. 4/3 times -10 is still minus. If we want to, I can just put a 1 there for help, and we can see 4 times 10 is 40. 3 times 1 is 3, and that does not reduce, so that's as good as that one gets. Okay, so this is what it looks like for now. All right, well, because they want it in a special form, they want it in that general form, at this point, because we have fractions involved, so general form is needed. Usually with these fractions, we don't like them. We'll multiply all terms by the denominator of that fraction. Well, fractions. So what we're going to do is multiply all of these by 3. So times everything by 3, and I'm going to show, so it's to 4 different values. Okay, and when we do that, well, 3 times y is 3y. 3 times 8 would be 24. And then multiplying the 4/3 by 3, so this is why we do it. This 3 and that 3 in the denominator would just cancel. So this would be 4x minus, and again, when this 3 in the blue multiplies the 40/3, the 3 in the denominator would cancel out, and we'd be left with just the numerator like that. So that's why we do it, because now it's getting closer to the general form. General form, they don't want fractions involved. They want something like this. And then they want your x's and y's to be together. So let's go ahead and subtract the 4x to the other side. And I'm just putting it way to the other side. And let's do 2 steps in one. Let's also get our constants together. So let's minus the 24 on over as well. Okay, so we'll have negative 4x, and then it would be plus 3y. The 24 minus 24 is 0, so now we have equals. 4x minus 4x was 0. We don't need to write that. And then negative 40 minus 24 would be negative 64. All right, and then now we just have one last step. So it is in the form that they want, but they want this to be a positive value with the x. So that means we'll do one last thing and multiply everything by negative 1. So, and now all that does is just change the signs. So it would be positive 4x minus 3y equals positive 64. And there we go. Okay, so that's our final equation. One thing I forgot to check in both of these is they said there should be no common factor. So like on this first one, 3 and 1 are not in common. Same deal with 4 and 3. They're not in common. So a common factor would mean if you could divide them by the same number besides 1. So like if it was 8 and 4, those are each divisible by 4. So that means they would want you to reduce it in some way. Okay, so anyway, so chances are, though, it shouldn't really happen as long as we break it down in the same old process. Okay, so let's look at one other problem here. So we've got the line L passes through these 2 points. Find the equation of the line in both point-slope form and general form. Okay, so the two kind of not outcast, but the ones that aren't as common. So one more time to reiterate, let me scroll up. Our slope-intercept form, so the ones that are answered on this, like these, that's usually the way they want it. Okay, so those 5. Okay, however, again, they're just kind of mixing it up, just seeing if we can play around with the equation and be okay with it. All right, so on this, it says line L passes through those 2 points. So we could sketch that. Let's go ahead and sketch it. So we've got 2 and negative 4, and then negative, there's the point, and then negative 6, and negative 7. Okay, so we can see that it's going up from left to right. So this is our line L. They want to find the equation of a line in point-slope form and general form that is perpendicular to this line. Perpendicular, remember that means opposite reciprocal slope, and passes through this point. So this is the point that we have. So they're giving us the point. Let's go ahead and put it way over here. So the point that we're going to use is this one. So not those other two. Those other two are important, but not for what we'll start to plug into our equation. So we have our point, and we need the slope. So the slope, though, is the opposite reciprocal to this slope. So let's go ahead and find this slope real quick. I'm thinking I'm just going to draw in my rise over run. And from there, actually, let's go ahead and use the equation. Okay, so this is the slope for that line, L. And we'll plug everything in. So here's where it's a little confusing with our x1 and y1. This x1 and y1, this is for the second part of the problem. These, so I'm gonna recycle. So I'm also gonna call these x1 and y1, and then this one x2 and y2. But this is only for line L. For L. So this is for our other line that they want for needed line. Okay, so these are different lines. So that's why it's a little weird. This x1 and y1 are not that x1 and y1. It's for a different line. Okay, but let's go back to the slope and find it. So if we plug all this in, so y2 minus y1, so we've got, oh, I did there we go, sorry, y1 was supposed to be y2 there. Okay, so x1, y1, x2, y2. So y2 is negative 7 minus y1, which is negative 4, over x2, which is negative 6, minus x1, which is 2. And then let's continue simplifying. Okay, so it's really negative 7 plus 4, and then negative 6 minus 2. Negative 7 plus 4 is negative 3. Negative 6 minus 2 is negative 8. Two negatives become positive. 3 over 8 does not reduce. Okay, so this is the slope for this line L. Okay, so we've got m equals 3/8 for the line L. Again, we want perpendicular to that line L, so let's mark it up here. Okay, so our slope that we really want is opposite of 3/8, so opposite of positive is negative, and then flip 3/8 to be 8/3. Okay, so these are what we really want. Let's go ahead and box it. Actually, oops, I kind of rewrote it. So I got plenty of room on this. So we have everything that we need now. So the point that we'll use, so for desired line, we've got the point is the negative 4, 3, and the slope is negative 8/3. And then now we can do it where we set it up as y minus y1 equals our m times x minus x1. We can plug all that information in. So we have y minus, so that's our x1, y1. So y minus 3 equals negative 8/3 times x minus negative 4. Okay, and then this is actually, so let's do one step here where I'm going to combine that into plus and then just kind of get rid of the parentheses that are no longer needed. So let's write it as y minus 3 equals negative 8/3 times x plus 4. So this is the answer in point slope form. So they said they wanted that. There it is. So might as well go ahead and box it. Ooh, got a little wild there with my box. There we are. Okay, so that is point slope form. That's what they wanted in one of those. And then they also want general form, the general form. So the general form is our ax plus by equals c. All right, so let's break that down. So we'll go ahead and distribute. So we've got y minus 3 equals, as that distributes, we would have negative 8/3 x, and then minus 8/3 times 4 would be, so 8, 16, 24, 32 over 3. And then we see, well, there's a fraction here. General form, they don't like the fraction. But it's a quick fix. We'll multiply everything by 3. So all 4 terms here get multiplied by 3, which gives us 3y minus 9. And the reason we're multiplying by 3 is to eliminate the denominator. So we have equals just negative 8x and just minus 32. Okay, so we no longer have any fractions, and then we want the x's and y's to be together on the same side. So let's add the 8x, and then let's go ahead and do 2 steps in one. Let's go ahead and add the 9 on over. So we've got 8x plus 3y equals, okay, so the 9 zeroed out, that zeroed out. Negative 32 plus 9 is negative 23. And there we go. That's it. That's what they wanted. So that's our general form answer to this equation. Okay, so we got them both. So point slope is kind of the first one that we should get, and then general form is broken down later. Okay, so there it is. So that's breaking down every little piece to these problems. So the main thing still is if they ever tell you to find the equation of a line, so all of these, so we just did, well, counting, well, I don't know where that one went, it erased. But we did it, right? Okay, so anyway, so we did some problems in a previous video, but the main thing, if they ever ask you to find the equation of a line, you need those two. Find the slope and find a point. Get those. They usually give you the points. And then from there, start to plug in and break everything down, and you got it. Okay, so but there are some slight differences from problem to problem, but you got it. With enough practice, it makes it perfect. All right, well, anyway, that's it. So if you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.